Measurement scales. Measurement is the assignment of numbers to objects or events in a systematic fashion. Measurement scales are critically because they relate to the types of statistics you can use to analyze your data. An easy way to have a paper rejected is to have used either an incorrect scale statistic combination or to have used a low powered statistic on a high powered set of data. Following four levels of measurement scale are commonly distinguished so that the proper analysis can be used on the data. A number can be used merely to label or categorize a response. Nominal scale. Nominal scales are the lowest scales of measurement. ये measurement का सबसे lowest scale है. A nominal scale, as the name implies, जैसा कि नाम से जाहिर है, is simply some placing of data into categories. इसमें data को हम मुख्तलिफ categories में रखते हैं without any ordering or structure, बगैर किसी तरतीब के. You also only allowed to examine if a nominal scale datum is equal to some particular value or to count the number of occurrences of each value. इसमें हम देखते हैं कि हर नंबर जो है वो कितनी दफ़ा आ रहा है. फॉर एग्जांपल, categorization of blood group of classmates into A, B, A, B, O in the only mathematical operation we can perform with nominal data is to count. Variables assessed on nominal scales are called categorical variables. Categorical data are measured on nominal scales which merely assign labels to distinguish categories. For example, gender is a nominal scale variable. Classifying people according to gender is a common application of a nominal scale. हमारे पास एक कॉमन एग्जांपल है क्लासिफाइंग पीपल अकॉर्डिंग टू जेंडर. जेंडर के लिहाज से क्लासिफाई किया गया स्टूडेंट्स को इज अ कॉमन एप्लीकेशन ऑफ नॉमिनल स्केल. नॉमिनल डेटा. क्लासिफिकेशन और कैटेगराइजेशन ऑफ डेटा. एग्जांपल, मेल और फीमेल. नो ऑर्डरिंग. Example, it makes no sense to state that male is greater than female. Arbitrary labels, pass 1 and pass fail 2, etc. Ordinal scale. Something measured on an ordinal scale does not have an evaluation connotation. You are also allowed to examine if an ordinal scale datum is less than or greater than another value. For example, rating of job satisfaction on a scale from 1 to 10 with 10 representing complete satisfaction with ordinal scales. We only know that 2 is better than 1 or 10 is better than 9. We do not know by how much. It may vary. Hence, you can rank ordinal data, but you cannot quantify differences between two ordinal values. Nominal scale properties are included in ordinal scale. Ordinal data are ordered, but differences between values are not important. Difference between values may or may not seem or equal. Example, political parties on left to right spectrum give labels 0, 1, 2. Example, Likert scales rank on the scale of 1 to 5 your degree of satisfaction. Example, restaurant rating. Interval scale. An ordinal scale has quantifiable difference between values become interval scale. You are allowed to quantify the difference between two interval scale values, but there is no neutral zero. A variable measured on an interval scale gives information about more or better as ordinal scales do. But interval variables have an equal distance between each value. The distance between 1 and 2 is equal to the distance between 9 and 10. For example, temperature scales are interval data with 25 Celsius warmer than 20 Celsius and a 5 Celsius difference has some physical meaning. Note that 0 Celsius is arbitrary so that it does not make sense to say that 20 Celsius is twice as hot as 10 Celsius. But there is the exact same difference between 100 Celsius and 90 Celsius as there is between 42 Celsius and 32 Celsius. Students' achievement scores are measured on interval scales. Interval data, ordered constant scale but no natural zero. Differences make sense but ratios does not. Example, 30 degree minus 20 degree is equal to 20 degree minus 10 degree, but 20 divided by 10 is not twice as hot. Temperature, dates, temperature in Celsius and Fahrenheit. Dates, ratio scale. Something measured on a ratio scale has the same properties that an interval scale has except with the ratio scaling. There is an absolute 0 point. इसमें 0 point आ जाता है. Temperature measured in Kelvin is an example. There is no value possible below 0 degrees Kelvin. It is absolute 0. Physical measurements of height, weight, length are typically ratio values. Weight is another example of 0 pounds is a meaningful absence of weight. The ratio holds true regardless of which scale the object is being measured. Example, meter, yard. This is because there is a neutral 0. Ratio data, ordered, constant scale, net, neutral 0. Height, weight, age, length. One can think of nominal, ordinal, interval and ratio as being ranked in their relation to another. Ratio is more sophisticated than interval. Interval is more sophisticated than ordinal and ordinal is more sophisticated than